Hello, everybody, and thank you for attending today's webinar. We'll be discussing industrial design with aluminum in RISA 3D. Let me see here. As most of you know here, we have several products available, but we have added recently aluminum into RISA 3D. Just to sort of give you a quick idea of some of the other products we have available, RISA Floor and RISA 3D work together as a building analysis tool to carry your loads down the building in the gravity loads we do in RISA Floor, and it hands the model off to RISA 3D for the lateral design. In that same model, you can take that into RISA Foundation to do your whole building design. All of those products also can work on standalone, and what we'll be doing today is just RISA 3D as a standalone product. RISA 2D is very similar to RISA 3D, but you're working in 2 dimensions. We have RISA Foot, which does footing analysis there and design. We have RISA Masonry for masonry walls. We have RISA Base, which does base plate design. RISA Section is a section properties calculator. And then we also have a brand new program called RISA Connection, which will do the connection design of steel connections there. So today here we'll be talking about aluminum design specifically in RISA 3D and how it was implemented in RISA 3D. First thing we'll be doing is building a model. We're going to be using some high-level generation tools, some copy modify tools to help us design that model, and sort of a couple different, we'll actually be doing 2 models today, and we'll be working with these different types of models to see how we can implement that with aluminum shapes. But I'd like to give you a little bit of a background on some interesting modeling tips too. So we have kind of two different approaches on this model, on this webinar. So one to help you get further design there with the modeling tips, but also understanding how you're using an aluminum. So we'll also be getting into loading. I wanted to show you the different types of loading we have available. The point loads we'll be doing area loads, and we'll also be adding moving loads into one of the models. We will also work with tension-only members in one of our models to see how that works. And then in all of the models here, we'll be working with aluminum design and results review. So we'll make sure that we do the detail report. We'll be going through the optimization using the aluminum design there. And then design rules will help us actually limit and get to a better design. So when we first start out here, what I'm going to do is we're actually going to be building this very first model on the right corner, and then the second model we'll do is this one on the left. So trying to give you kind of an idea of the different types of things we might be able to do. So let's start out by opening up our RISA 3D model. And the very first thing it does is open up. And today here we said we're going to be doing aluminum as our very first thing. So what I always try to do when I open up a brand new model is jump into RISA 3D, and I'll hit up the global parameters, which will open up here in just a second after my screen refreshes. And the global parameters, there's going to be something here. So we're going to say close, and we're going to pop up into global parameters. And what we're going to always sort of jump into here is to put some information about our model and some solution information. But what I always jump here is going to be to my code section. The very first thing I want to make sure is that I'm using the right design code. And so for aluminum here, we can see at the bottom was added there. We have aluminum design for building and for bridge. Now with that building and bridge there for the ASD, the ASD design is going to be the aluminum design manual there for 2005. And what we're going to see is the building. I'm going to just stretch this over here so we can see a little bit. Let's see here. We can see both things at the same time. So now for the what you tell your program here is if you're using a building, you're going to be using the safety factors here from the building column. If we're going to be using the bridge, we're going to be using it from the bridge column. So that's model-based, and it will assign all of the different safety factors for your entire model. So we'll be setting that up and say OK. And the next thing here we're going to do is jump into the materials spreadsheet. So on my data entry toolbar, I'm going to open up the materials spreadsheet. I'm going to go over to aluminum. And when I look at here on the aluminum, I've got a lot of different properties in here started out as a default properties. So what we'll look here, we've got, looks like 6 different properties, and we're going to be using kind of a variation of some of these today. But what we can see here is that we've got the standard stiffness properties like your elastic modulus, you've got your shear modulus, your Poisson's ratio. If you're going to do any thermal loading, you have thermal expansion. We've got our density listed there. And then the other important items here is this, we have table. This table 3.3 is coming right out of the code. And we can open up our little sheet here again and see where this comes from. So in your code here, in your in your aluminum design manual there, ADM, you're going to find two tables. One is the table 3.3-3, and then the 3.3-4. So either one of these tables are going to be applied to your materials there. And we're calculating all of these values for you, but we do need to know which table you'll be entering into. So is an ability to have you be able to design many more than just what we have as these defaults. We've given you the ability to toggle between those two tables. So you really can customize if you need more than these materials that you have here listed. The KT value there, so we're going to see that that's going to be your values that are coming out of your table 3.4-2, the coefficient there, and you can set that for your tension members. And then these values here are going to come right from the code, from the allowable strengths there that you've got, the ultimate strength, of what you got in here. So you can fill these right in as well. And your CT is also coming off that table 3.3. Now, if you ever get confused about what of any of these things are, you can always either, at the bottom of my screen, I have something that says the information about what it is. It says buckling constant for aluminum alloys. But the other thing I can always do is push the help button, and it will pop me right into the help, and it will tell me a little bit more about where I'm looking at these different items in here. So the help is always a good resource in anything that you build here in RISA 3D. So I'm going to close, we'll look at materials. We've got that all set up. The next thing what we're going to do for our model, we're going to be building that frame that we had just seen. And what we're going to use is section sets. So if I click on section sets, I now have an aluminum tab here listed at the end, and I can click on that aluminum. And what I'm going to do is use section sets to help me lay out some common items. Like columns are going to be all similar. Joists, I'm going to use similar items here, girders, and I'm going to call the next things braces. So if I just call them all the same thing here, what we're going to do is have a common material or common shape for that single item. So for columns, for example, you typically would use the same type of column around your building. And maybe one or two would be some special columns, things like that. So what I've got here, I'm going to call out columns. I'm going to come to my columns here, and I'm going to see that I can choose from a whole long list of different aluminum shapes. I've got wide flange shapes available to me here, and I can see I've got a long list of wide flange, Army, Navy shapes, US shapes here. I've got Z shapes available. I'm going to see T's, which are listed here. I've got solid rectangular. I would have to enter some in there. I've got some angles. I can enter angles right directly in there. I have CS, which is going to be my channel shapes, and I can do channels there back to back or front to front. In either direction here, you can see that. I can also do round tubes, and then I can do rectangular tubes. For my columns here, I'm going to add some, we're going to use some American here. We've got, actually, this is all listed under my US, by the way. There's two databases, so you can flip-flop between those and go to the Canadian database if you're using Canadian shapes. So I'm going to use the aluminum US there, and I'm going to select my first shape here to be just, let's call it a 10 by 8.65. Okay, so that's my first wide flange. I need to tell the program that I'm using this as a column. And then what we have is something called a design list. Now this tells the program how I need, what list to select for suggested shapes when we actually want to redesign these members. Right now we're going to be running an analysis and checking that shape. But when the program sees that it doesn't work, or if there's a better selection, it's going to go to the rectangular tubes for me, which would not be what I'd want. I would want more of the AA wide flange there, and that would be what I'm going to actually use for selecting another type of column to redesign. So we'll see that actually in action in a little bit here. The material I'm going to use is going to be, I'm going to select on here is a 6061T6. Okay, that's going to be the first thing I'm going to choose there. And then the joists, I'm going to call these to be a channel shape. So if I come in here and I pick a channel, I'm going to pick something, maybe something a little smaller. Let's just pick maybe a 3-inch, or we'll give it a little bit bigger depth, maybe a 6-inch there. And we'll say that's going to be a beam, and make sure to choose it on the channel shape. And then we'll choose here, I'm going to call this 606T6. Let's see there. Okay, so we've got, actually, what was that, 6063. So we've got all that listed here, and we're going to use the girders now. The girders I'm actually going to do as a wide flange as well. So I'm going to click on the wide flange, and I'm just going to use maybe something a little smaller, maybe a 6-inch wide flange. And I can call that a beam. And I do need to make sure I select the AA wide flange, and I'm going to use the 6063 there. And I'm going to do the next thing I'm going to do is a brace. The braces are going to be, let's call these braces actually, we're going to use round tubes for the braces. So for the round tubes, we've got a lot of different types. We have shapes here already available. The outer diameter is the first number there, or you can use some of the NPS there. But I'm going to choose some of these smaller ones, and we'll see how they do. We'll start with something more like a 2-inch, a little bit larger here. And that we're going to call a V-brace. And so we've got that all started out. Okay, so the next thing we're going to do here is, and we're going to make sure we set up the 6063, and we're going to make sure that we have a design list choosing a pipe shape. Okay, so now we have our section sets all laid out. What we can do now is I'm going to close that out and start laying out some geometry. So one of the tools we have available is this high-level generation tool. I have some ways to draw in some members automatically using a grid format. So if I click on this 3D grid for members, what it's going to allow me to do is put up pretty much a frame together real fast by just giving it some quick dimensions. So in X, Y, and Z, I have 0, 0, 0. I see in the X dimension I'm going to put 18 feet, which is, if I look at this picture, it's going to be dimensioning it in the direction here we see with X-axis members. And the Y direction is going to be my vertical direction, so I'm going to tell the program to do that as a 10-foot frame. And then I'm going to give it a couple Z directions for those bays in that direction. So I'm going to say it's going to be 16 feet in that direction and 16 feet in that direction. Now, since I've already laid out section sets, I can tell the program right here directly that I want to use section sets in the X direction. And I'm going to choose those to be my joist members. And then in here, I'm going to turn my Y-axis members to be my columns, and I can pick this from the list. And then I can define the Z direction to be my girders. So once we lay all this out, I'm going to just say OK. We see we have a kind of a start of our frame. So it's just the basic beginnings of what our frame is going to look like. The next things we can do is we can lay out some more framework here. I'm going to close that down and just go into the isometric view. I'm going to turn off my grid because we're not really drawing with our drawing grid today. So the next piece I'm going to do is sort of draw this back side of this frame. It's going to kind of fill out here in the more of an L shape. So to do that, I'm going to click on my high-level generation tool one more time, click on this grid members, and then what we did when we started this is we used it in 0, 0, 0. Well, this time we're going to do is we're going to set it back in the Z direction so it fits itself back there, and I'm just going to do it as a negative 15 feet. So it'll be just behind the frame we have currently. Now, you'll see everything gets remembered, which is helpful there because I can just sort of use some of the numbers I already have in here. I'm going to just use a 3-bay system in the X direction now, and I'm just going to tell it to be 15 feet in the Z direction. Okay, so we've got it all laid out. I don't need to do anything else on the lower portion. It just remembers where it's laid out. So I can say OK, and now I see I kind of have 2 whole frames worked out for me laying in those directions. So the next piece I'm going to want to do is really fill in those joists that I had laid out. So what I'll do to do the joist is what I might do is just unselect some of my members, and I might, if I forgot what that dimension happened to be, I can use what F5 button. It looks like it turns my whole icon into a distance button, and I can just measure what that is right there. And at the bottom of my screen, it tells me it's 47 feet. Okay, so what I might want to do is copy some of these members to go along that 47 feet. So I can unselect everything and just copy this. This is a joist, and we can just double check that by clicking on it and making sure that its properties are a joist. We see its general properties here. And I'm going to copy that in the direction that we have. So what I'll do here is click on my copy button, and I'm going to copy it here in the Z direction. So I want to put it in the Z direction, and I'm going to tell it 11 increments at 4 feet. So that's the number of increments and then the number of feet there. And I just say copy, and it lays those out for me in place right there. So I have starting out with my joists in place, and I'm just going to select a couple in this direction and copy them in the other direction, so in the X direction. So I copy them, and I'm just going to say clear because it does remember what I just did, and I'm going to say 2 increments of that in 18 feet direction in the X direction. And just say apply, and I get sort of a grid laid out there. So it's real easy to sort of get everything laid out in that grid format, but what we will notice is that everything is fixed right now. So what I do want to do is make sure that I set my end releases to the proper end releases. So what I'll do is I'm going to unselect the entire model, I'm going to use my selection criteria button on the bottom here, which is this little red question mark, and it's going to help me find the members that I'm looking for. So I'm looking for to select only the joists and the girders on my screen right now. So if I use my section sets, I can find my joists, and I'm just going to say apply, and it picks out all the joists. And then I'm going to say pick out the girders as well, and it picks out just the girders, and I can say OK. So now none of those columns are being selected, and I can make mass modifications to these items that are selected. So if I click on the Modify button at the top of my screen and Members, what I'll find here is it's going to give me a whole array of different things I can change. But what I'm interested in is changing its bending moment released on both sides there, of start release and the end release, and applying it to all the members that are selected on my screen. And I'll see now I have pinned connections on all the ends of those members. So we're not carrying moment through those ends, we're just carrying shear. What I also do is I do notice that I have a lot of members at the very bottom, and I'm going to really probably take a lot of those members out. So what I'll do is I'll use some of my viewing tools to unselect everything, and I'm just going to select things just in that direction. So I'll just highlight the items. These are all our basic joists and girders in that direction on the bottom of the model. And I'm going to use my delete button to delete these. And the delete button will allow me to delete based on this criteria. It's going to delete all the members that we have on our screen and just say apply, and all those go away. So you typically don't need those bottom members because we're going to do things like our boundary conditions to support that base of that model there. So let me just do that before we get ahead of that. We can put our boundary conditions on the bottom. So I'm going to say Modify Boundary Conditions by just clicking on that button there. And I have a lot of options here to do fixed boundaries, pinned boundaries, rollers. I'm going to tell the bottoms to be fixed there. I'm going to say Apply, and I can just highlight them by boxing the entire bottom of my screen, and I see that it fixes the base of all those columns. So it's real easy to lay that out. And the next piece I'm going to do is I'm going to give myself some stability in this model here with some braces, but they're going to be tension-only braces. So what I'll do here is I'm going to click on the Draw New Members, and we just choose the aluminum. And you can, now this is from drawing the members individually. We were using high-level generation tools. We could have built this whole model using our drawing members here this way. This is a lot faster to use our generation tools. But here we're going to choose assign a section set. Since we spent the time to create a section set, what we can do is select from that section set the braces, and we're going to tell these braces to be pinned at both ends. And one of the things we're going to use on this is tension only. So what I'm telling the program is that this member can only go into tension. And what we'll see is when we run the analysis, that means that when it goes into compression, it gets removed from the model and iterates to another solution. So we're going to watch how that affects our model a little bit. And I'm going to say Apply, and I'm going to just draw some of these around my building a little bit just to help me support my lateral system. So I'm going to just give myself a little bit of, I'm going to go here, and let's just sort of put some of these in here. So if we've got all of that in place, if you remember what we had in my model when we were looking at it in the PowerPoint, it was actually had a little bit larger portion. We had a whole right side of the model. So now that I have all my geometry laid out on the left side, I can just sort of copy all that to the right side since this is going to be a symmetrical frame for us. So I can unselect everything, and I'm just going to turn my model a little bit and use my selection boxing tool to just pick out that side of the model. And what I'm going to do is I'm going to copy it. I'm going to come into the copy button here and just clear everything. And then here I'm going to copy it in the X direction by 54 feet. And if I say Apply, I see that it comes over on the other side there. And I can now see I have everything in the model geometry-wise the way I want it to be on the left side and on the right side there. Okay, so what we're seeing in our model is we've got all of our braces in place, but the next piece we really need to do is lay out our loads. So under the data entry toolbar, I'm going to open up the basic load cases. I'm going to call this out as dead load, live load. I'm going to use wind load X in the X direction, okay, and then wind load in the Z direction. So once I've got these all laid out, now what it is important for me to do is use my categories. If I use my categories, it allows me to use my load combination generator as we come up here. And we can see we have a lot of different categories. Everything really that the IBC sort of requires there, but not, some models don't require as many as what we see here. So I'm going to say WX and WLZ. Okay, now to apply self-weight to the model, I do want to put a -1 in the Y gravity column, and that means that it'll automatically apply self-weight to the members based on their density. So now I can close that right up, and I'm going to start applying some loads. So the first loads we're going to do is some area loads. Now area loads you can find right here, apply member area loads. And when I choose on that, click on that, what this allows me to do is apply area loads to an entire area. It's going to distribute the loads in any of the directions I tell it, so the X, Y, or Z, or the projected X, Y, and Z, or the perpendicular. So I have a lot of different options here. I'm going to use the negative Y direction, and I use negative 0.002, 0.02, so 20 pounds per square foot, so this is in kips. And now you have a couple options. First thing we're going to see here, you have a two-way, which will distribute the loads in two ways, meaning in different directions. Almost here, if we were to imagine it would go in all directions, a two-way sort of, it makes sense like that. In A, B, that's the way I'm going to click the button. So we'll see here, if I click from A to B, the loads are going to be distributed in that direction. So I'll show that, and that's the best way to see it, is how it actually gets distributed. So if I say apply, I see that my joists are running in this direction on my screen. So if I click from A to B, and then I keep closing that loop with a rectangular, I see that I get the loads are going to be distributed along my joists, which is the way I would expect it if I'm running my deck that way. So same thing on the other side, I can say from A to B and click over there, and I'll see that goes in that direction. Now I'm just going to show you one wrong, and we'll see how that would work, is if I clicked it in this direction, that would show me that it's actually going to the girders and not applying anything in the direction of the joist. It says basically how you're laying out your deck. So I'm just going to push undo because that's not what we want. So we're going to say here, click from A to B, and then we're going to go from here to here. And we see that the loads are being distributed in that direction. So that's sort of how your area loads are. You just want to pay attention to how you click things so you get that directional loading properly. The next thing we're going to do is let's add a couple live loads in there. So assuming, and we can drop down to live loads so we don't have to see those dead loads. So assuming that we're working with a model here that's got some equipment loading on this. I would be assuming here, what I'm going to probably do is have some maybe equipment point loads on that model. So what we'll do is we're going to use in the Y direction, we're going to tell it to be a -1 kip. And I can tell it a certain location along a member, but I'm going to just say 25%. And I'm going to tell it to be in the live load direction. And I'm going to apply that right here on a member, and on actually two members. We're going to assume that those are sort of the bottom of two legs of an equipment rack there. And the same thing I'm going to do, now that's just two legs. Typically you're going to have four legs, right? So what we're going to do is just change this to be 75%. And apply it to the exact same members there. Now I can tell you right off the bat that we're going to probably have a problem with those members, and I have those in section sets. So does that mean that we're going to have to size everything up, or can we just size those two? So let's double check that. We can double click on that member, and right now it's a joist. But what I really want to do is make that its own type of member, and I really don't want to use section sets for just two members. So I can just click on the shape button and pick a shape from this list here. I can go straight to my aluminum shape here, and I'm going to pick a wide flange, something real nice and stout to support that onto the girder there. So I'm going to say let's just use this wide flange there. And I'm going to pick that, and it's going to get started with that right there. So we will want to make sure that we use the same material there. So we'll pick something, maybe we'll keep that as a 6063 T6, and then we'll call this, make sure this is a wide flange if we ever do need to size this up in this area as a beam. Okay, so what we can do also is do the exact same thing on this shape, and we can tell it to be an aluminum wide flange, and we'll choose that there. And we're going to choose that we've got it actually all laid out there. I just need to make sure that that gives me a nice suggested shape if we do need that. So I can say OK, and we've got it all started out. So if I render this real quick, we'll just see that those are sort of the bigger shapes there because they are carrying a little bit of load. Okay, then so we've got our point loads in place, we've got our area loads in place. Let's put some actual wind on this model so we see some different lateral loads happening. So I'm going to again use my area loads. This time I'm going to use in the X direction. Okay, I'm going to tell it the X direction, I'm going to put 40 pounds per square foot, and I'm going to use that in the AB direction, and I'm going to say it's wind load in the X direction. Okay, and then we're going to apply that right here. And we're just going to do A to B so it loads up my columns, and then I see that there. It's going to actually be applying it right directly on my columns there. The next thing we'll do is we'll apply some wind in the Z direction, and we'll just need to change our load direction to the Z. push apply, and I rotate this. Oops, let's just get this a little rotated so it's easier to see. And I'm going to click on A to B and click a couple more nodes here, and this is going to get me in that direction. Now, whoops, I sort of made it in the weird direction. I always like to see at least my first load coming in the other direction. So what I'll do is I'm going to just jump right into my basic load cases spreadsheet, open that up, and I can just make a modification directly to this number right here. And I didn't mean to push enter, and I can see that it flips the load for me. Okay, so I've got loading in that direction. Now, you can toggle between your loads pretty easy. You just drop things right down here, and you can see that we can see the different loads we've got right there. Okay, so it's so easy to see all that right on your screen. What let's do is add some load combinations. So first thing we'll do is we're going to open up our load combination spreadsheet, and it's blank right off the bat, but we can create load combinations using our LC generator. So I click on the LC generator, and we didn't use roof eye loads, so I'm not going to use that or snow loads or rain loads, but I do want some gravity gravity cases here. So I'm going to just say generate, and it's going to generate 2 gravity cases for me. Then I'm going to go to the wind tab, and I'm going to switch here, and I know I use the X and Z wind load directions and categories, and I do want to make sure it's reversible. So if I have all that laid out and just say generate, I see that it generates all of the wind cases for me. So quickly it laid out 11 different cases for us, which was pretty easy to do, and I'm just going to run an envelope solution now that I have that all done. Okay. So with everything in place here, I've got the model running, and it's going to go through a load combination. If you see at the bottom of my screen, it's using a solution iteration. It's going only about 2 iterations, but what it is doing is applying that wind load in either direction, and when different members go into compression, like we told them they were tension only, they get removed from the model. So we'll see that in a second. I'll just show you how that works. But let's review our results and how far we did so far. So what we have so far here, if we look at the results, we're going to look at our design results on our screen, and it pops open to steel, but we're going to go over to the aluminum tab, and we're just going to see what happened in this model here. So we've got a lot of failing members. What I'm looking at here is first is the shape, and then I'm looking at the code check, and that's going to be your bending check. And I see, and whenever it goes over 1, that means it's over a unity check of 1. So those are failing members. And I've got the load combination that governed there. Actually, excuse me, the location. Then I've got the load combination, and then it tells me the shear. Now that's a lot of information. What we can do is just click on that and sort it. So we're looking at it as the absolute max to the absolute min. And I see, wow, there's a lot of 9.999s. And those are the ones that are just off the top. You know, they really aren't even being calced at that point. They're too high. And that makes sense. I give it sort of an odd, smaller shape, right? So we do need to sort of make an attempt to size these up a little bit. But what we can also do is we can take a quick look at our model and see really where it is failing. So I'm going to turn the loads off for a second, and I'm just going to unrender this. And let's take a look on the screen. We can go to plot options under members and turn on our color-coded unity check. So it's going to tell us exactly what's failing. And no surprise there, right? Those are the joists and the girders that are failing. And I'm just going to close out these data entry toolbars. And we see that here with the legend that anything over 1.0 on the unity check is giving us a red. Okay, and anything under that, the 9.0 there is going to give us actually different colors there. So, and if it was real bad with no calculation possible, we're going to get a black. But I don't see any of those. Okay, so let's also do is let's take a look here. I'm going to look back on my results toolbar, and first thing we did, so we saw that we had the design results. We've got exactly what's failing. It gives us a lot of the allowables here listed out. It gives us the equation that controlled for that code check. So these are going to give us all some combined checks here that are causing us failure. So before we really dive into these results too far, each load combination, I want to show you how things work in each load combination, but I do think we should sort of take a better stab at those joists because they're really just sort of failing too bad. So one of the things we do here is we have a suggested shapes. And in the suggested shapes, which is right above the design results, the program tells us what it would be doing better to be using this better shape rather than the one we used. So for columns, it wants to use here an I 12 by 14.3, and there's a controlling member that's causing that. We can see here that there's some, our joists want to go up to a 12 by, okay, which makes sense, and our girders maybe want to go to a 9. Well, that's sort of weird, right? We don't want to have a joist that's bigger than our girder. That kind of seems odd to me, right? So what we can do is we can set up some design rules to make us have better results for those actually there. So what I'll do is I'll go in my data entry toolbar, and I'm going to open up my design rules. And these design rules really help you get a better design or a better suggested shape. So what I can tell the program is the minimum depth for my, let's call these my joist / girder, and it doesn't matter what you label it, okay? That's just sort of for your use. The minimum depth is going to be a 10-inch, and the minimum width, we'll say minimum depth. Well, that's really what we're concerned in there. But let's say that this is a platform that we don't quite know what we're going to be doing yet, and that we've only really got some information on a little bit of the loading there for the equipment, but I don't really know properly what the full loads are. So what I'd like to do is design it to 90% of the bending check and 90% of the shear check. So we don't fully go to the full extent of what we've got there. And then I'm going to just give myself a default there. So I have sort of a joist girder and a default. And I'm going to open, that'll be allowing it to everything go to 90% there. Okay, so the rest of the model will be at 90%, and we'll just call this all. Okay, so we'll have everything else to be all, and then the joists and the girders will be that. So what we can do is we can select only the joists and girders on the screen. Okay, I'm going to pick up the girders, apply that, and I'm going to pick up the joists and find that. And we can use our modify tool here, and we can modify our members. I'm going to go over to the design properties, and I can tell it to use the design rules here that I had just created, the joist girders, and say use, and apply these to all of the ones that are selected on my screen. Okay, now I can use a flip-flop button and check all of the rest of them and say modify those design parameters to be the rest, or what we called as all, and just say apply there. So now when I use my solve button, I solve as an envelope, now my design is really based on something that I want, okay, so not quite sort of this random selection from the suggested shapes. It otherwise now is going to give me a better idea of what I want to be using on those. So we run through again. You see there's a little iteration. Whenever you have tension only, you're going to see a little bit of iteration happening. We didn't really do anything except to the model, except tell it what betters the suggested shapes are. So when we pop over to the suggested shapes, we're going to get some better ones here on the joists and the girders, things like that. Okay, so first of all, let's switch our joists and girders. Okay, that was the only thing I'm going to let it use as suggested. And if I'm going to solve again using these suggested shapes, it's going to run through the model and so use those as the suggested shapes. So now I'm rerunning the model. Okay, I'm going to get a different solution this time. And we're going to see just a little bit how much better we did. And since it is color-coded on my screen, it's really nice. It's quick, and we see everything is in blue. So we did pretty well compared to what we just did. Let's take a look at the design results and see where we're doing here. So I'm going to use to sort this, an absolute max to absolute min. So it looks like we do have 2 columns, and those are the columns because I just sort of cheated and looked at that red on my screen. Those 2 columns there, back there, are still failing, but the rest of everything is passing. Okay, so we did pretty good on everything else. But why are those two columns failing? Let's take a look here. If we look at the load combination was 6, that's the one that's governing for that failure. So I really want to investigate what is that load combination. First of all, what is load combination 6? So we open up the LC, load combinations, and we can see 6 was the wind direction there. And we can turn on that wind just so we understand what is that load there. So we can see the wind load combination 6 is blowing sort of against that model there. One of the other tools that is really helpful, and I really can't stress enough how much this helps me understand models, is to go into the deflected shape. And what I can do is come in here and turn on the load combinations here for the deflected shape. Let's see, I'm going to run just load combination 6 for a second here. Let's see, so load combination 6, I'm going to say solve, and I'm going to solve that load combination 6 by itself so I can really see what happens in that deflected shape. And I pop up that load combinations, and now I can see, whoa, okay, yeah, that's failing, right? So now you kind of understand, okay, well, even if it was passing, right, it's too much deflection right there. So sometimes the deflected shape really gets you an idea of what happened here. You could look at your joint deflections, which I really would suggest. Gosh, we have some big ones in there, right, with a 5-inch deflection. So either we decide that maybe we need a little bit more bracing, or maybe we size that up. But let's take a look closer at that detail report, because really what we want to understand is how aluminum is working for us here. So if we look at our detail report and click on that detail report, this is for the failing column, member 46. And if I open up this detail report a little bit, first thing I see is I get some axial loads in there. I've got some deflections in there. We got some big deflections, right? So 5 inches is pretty big. I've got some shear and moment. Okay, so all of this is happening. All of these are interactive, by the way, so if I want to click on a moment diagram, I can see exactly along the way what's happening, what's going on along the distance, and you can see if we had any kind of strange loading along the distance, it would give us some better idea. This is pretty uniform, so not too difficult stuff. But what we can see is if we scroll down, this is the code check information that we really want to dig into. Okay, so this is where I would really start to say, okay, what's going on in this number and how do I understand this? So let me talk to you a little bit about, let's pull up a code reference and see where this comes up with. So first thing, we have a max bending check, and that tells us here what equation is governing, and it's the 4.4-2 from the ADM 05, and what we see in there is that that's a bending, combined check with bending, compression, and shear. Okay, so there's a little bit of everything happening in this model, and that's evident here. We also see a shear check, and that's a real low, so it's kind of low on our radar. But what we do have here is kind of a different type of table that gives us some information. And what this table is based on, I'm going to open up my Word document here on the side so we can see a little bit better, is this detail report here is really based off what we use as the design aids. These are numbers that you could basically calculate. We could have given you here just the equation and maybe just the allowable, but I think that this really gives you a better idea of what's happening in the model. So if we look at the very first thing, we see that the tension number is 19, and that 19.487 KSI comes from equation 3.4.1-2. And so if I look at this this design aid, this is for my material, 6061T6. Let me make sure I'm using that one before we go into this. Yep, 6061T6. Okay, if we look at 6061T6, I get now the material here is 19. If I look at the number we presented here, oops, sorry, lots of things going on at once here. The number we presented was 19.487, and from the design aid here, I see it's 19 actually is what they sort of round in there. So we're doing we're doing the actual true calculation there, so we're going to see a lot more different numbers coming after that, but we're going to match that number perfectly with that tension number. Now, one of the more difficult ones is starts to get where we actually use these slender limits. So we can see here from the slender limit, I can see that I have a compression number. It's coming from 3.4.7-3. 3.4.7-3 is coming right out of this compression in columns. And if I scroll over, what I see in here is this one right here, this row. What I get to see is that this S number that we're showing here is the slender ratio is based off of here what we see in each one of these columns is based off something different. For this equation, it's the KL over R. So for this equation, it's 84.6, which is the KL over R, okay? And you see that value KL over R here. And if we're we would have to decide which table to be in. So if we're in the allowable stress, we can be right here from S1 to S2, between S1 and S2 there. I'm going to choose this range, and I'm going to find it. Our 84.6 is actually higher than that, so it's going to be on this side of the equation there. And so we're going to use calculations from that, and we're going to see that our value here is 7. Okay, so you're going to apply that. So this is actually taking that KL over R squared, and then we're applying it to this equation right here, and then we're going to be putting it here. If you actually go to the code, it's a lot longer-winded, but this is a nice, quick, easy way to see how this works. You can also see FBZ. So here we've got, we are seeing LB over RY. We're using RY effective, so it's a slightly different number than your KL over R. And we've got there, you apply that 77.4, and you go to the 11 equation. We scroll down on this list, and we see this is 3.4.11, and we can see that we use there, we've got the 77.4, and we're actually in the middle of this range. We're between 79 and 21. Now, it's always nice to be able to see that you've got 21 here and 79. So where does the slender ratio fit within these limits of S1 and S2? Okay, so you've got that. It's fitting right in the middle of those. So we're using this equation right here, and we can determine that number to be here. We see this to be 14. Okay, same things go as you go down the list here. You can use FBZ, FBY. Now F shear, we can see in F shear, we're going to 3.4.20, which is at the very bottom of this list. And now that one is using H over T. Okay, so you get a different H versus a different, with the different directions that you're looking at your shear, and if it's in the Z direction or the Y direction, so your H over T value. And you see where I'm pulling that out is right here, H over T. That's what we're pulling right out of that, and that's what we're displaying right here. Okay, so 14.6 is way below that, and so we're using the 12 number there, you see right there. Again, the same thing happens in the Y direction. It's way below that there, or slightly there, and you get that number. Actually, it's going to be right in the middle, sorry, living right in there. Okay, so you can kind of track down how these work, and it's a real nice way to say, oh, okay, got it, where does it fit? And sort of lines up to that compact ratio that we get more in a hot-rolled steel application. Is it compact? Is it non-compact, slender? So you sort of have that idea of that, where does the slenderness ratio fit inside of the limits or outside the limits on either side, and how do I calculate that? Okay, and then you can go back to the full code and run the full calcs, but this is nice and I think a lot easier to understand. We also do give you here the K over R. You get all your information listed out for you, so you can sort of backtrack into some of these numbers for yourself too. So that's going to be your detail report, and that's where you're really going to want to look at these numbers and see how we're actually calculating those and where they're coming from. So we've got this one failure. Again, we can use our, instead of sizing those up, we can size up the entire section sets. We can pop into here. We are using right now is a 10-inch column. Maybe we come in and choose this to be a 12-inch on our own. We could use our suggested shapes again, but maybe this time we just say, come on, let's do this as a 12. And we say, let's solve this again using our load combination 6, and we can see that there a little bit faster. That it's going to now still pretty deflected. Okay, so that might be something you start to control now is more of the joint deflection issue rather than a code check issue. I think that happens most times is your deflection becomes a little bit more of an issue than what you actually code check becomes, because we can solve this and sort this now. And oops, let's see here, that's fine. We're going to sort it, and I'm going to sort this in. We see now that we've got a little bit lower numbers. I'm going to sort that. Sorry about that. Absolute max, absolute min. So I've got a couple ones that are just still failing. One of the things I just want to show you before we kind of get out of the information here is we just ran load combination 6. And what we've got for load combination 6 is we are blowing wind against the building here, or against our frame. And we're using tension only, and I'd like to show you how tension only works a little bit too. So if I go in here into plot option and show you the axial loads on that, what we get to see is, I'm going to turn my loads off. What we see in this model is as we blow on the wind in this direction, we see tension in these braces, and we don't see tension or anything in these braces. And if I zoom in a little bit and I push on the detail report, I'm going to click on one of the braces, and we can see what the actual, let's see here, I'm having trouble clicking on it right now. Let's see, I'm going to just click on detail report real fast, and we'll click on this one for a second. So what happens on that side here is there's tension on the other side, but there's no tension on here because this actually got removed. There's no tension. So in theory, what happens is it's almost as if this did not exist. Now, if we run the loads in the other direction, what we're going to see is that we've got in the 5 direction is going to be solving it, and it's going to run the loads going in the opposite direction. I'm going to display that for you so you can see that. Loads in the 5 actually blows wind. There we go. Let's see, blowing wind in the load combination 5, which I think is the right one that we want to be looking at. And, 5 is the actual. We need 7, I think, which is going to be reversed there. Okay, so 6 and 5 is the ones we were worried about. 6, and let's open up this here. So 6 and 5 is the ones that we were worried about there. And so if I run 5, I can see that I've got different combinations actually going into different tension and compression directions. So it helps you see a little bit about how those are getting analyzed and what happens when they are being used there. So when they are being run as tension, we'll see the tension in there, but when they are not, when they're fully removed from the model, you're going to see that that whole detail report acts as if it's empty. It's really being removed from the model. Okay, so really kind of a good thing to understand how your tension-only members work. We also do have Euler buckling, so it will go to Euler buckling limits if you did need that. So if you're having a problem getting convergence, you can go to Euler buckling instead, which lets it stay in there for a little bit of compression, but gets pulled out when it gets too tight, over the Euler buckling limits there. Okay, so let's jump into our next model here. We're running a little long on this model, so I'm going to start a new model, and we're going to jump right into how to build that model. The model we're doing here is more of a frame system, but I'd like to build a model that's more of a, we've got more of like a street sign or some more of an actual kind of a sign thing issue here where you have lots of different types of issues happening on that. So starting out in this model, we're again, just open up our section sets. And we're going to just quickly jump in here and put some aluminum section sets for columns, and we're going to put in some webs, and we're going to put in some beams and sign support. Okay, so with all of that members in there in place, what I can do is we're going to use some different types of shapes, maybe some tubes in here. So I'll use some rectangular tubes, and we'll start with maybe a 6 by 6. We'll start with something a little smaller there, 6 by 6, and we'll see how that goes. And I'm going to call this as a column. I'm going to use a rectangular tube as my design list. Okay, and then we're going to say this is going to be a 6063 T6. Okay, so we've got all that laid out. I'm going to copy my tubes, and I'm going to use tubes that are all over. And the only place I'm not going to be using tubes is going to be, I'm going to make sure those are tubes, is going to be for my braces. My braces, maybe we'll call those out as pipes, just sort of to help us, so maybe round pipes there. And we'll just start with something smaller and see where we go. Okay, and then we'll call these as pipes. We'll call this all 6063, and we'll use a 6063 T6, and we'll match all of this material. Okay, so we've got all of our materials laid out. We've got all our columns and webs laid out. Now our section sets. Now let's just start drawing a couple things. So it's real easy to draw in some models from scratch without using any of the high-level generation tools. You can just sort of draw in, say apply. I'm going to just draw using my drawing grid. I'm going to draw an 18-foot high column, and I can just quickly draw using that drawing grid in there. I'm going to draw in some of my webs, and so I click on webs, and I'm going to make sure these webs are pinned at both ends. And I'm going to call these here, I'm just going to give myself a little bit of a more of a lattice type shape here. And I'm just going to copy that up. I could keep drawing and drawing, right, but we'll run out of time before I finish drawing. So I am going to use a lot of my tools to help me get this much faster. And you always kind of want to get your model as fast as possible there so you don't spend time modeling, but more time understanding and designing, right? So I can copy that up the building by 2 feet all the way up the building, and I see I get all new webs in place there. And what I can do now, this is a 2-dimensional model, but what I can do to get this all oriented is I can copy and rotate it. I'm going to make myself a 3-sided tower. So if I use a copy rotate tool and I make this copy rotate in 60 degrees, I just tell the program 60 degrees, and it goes out by 60 degrees. I'm going to get rid of that drawing grid now that I'm done with it, and I can see that helps me in 60 degrees there. But now what I want to do is close out that top of that, and it's kind of hard to close it out if we're drawing, things get in the way. So what I'm also going to do is just do another copy rotate and click on that there, and this time I'm going to use it to be a -60. But it won't just work that way. I have to change my origin, my polar origin, to be here at 2 feet in the X direction. So if I say apply, now I see it closes everything out for me. Now what is interesting when you do sort of these copy rotates, it's real helpful, but you will probably think that, hey, I did probably do a lot of copying and rotating of things on top of each other. So I will want to just model merge a little bit, and we'll do that a little bit as we use a lot of these tools. So I'm going to do is unselect everything and just select my members here, my axial members, and excuse me, I'm going to select everything on my screen here, and then I'm going to unselect just my my webs. So if I unselect my webs, I can say OK, and I'm going to just do a quick model merge, and model merge only the selected items. One of the reasons why I only did the selected items and I didn't model merge my webs is that I would have gotten a little node that would have been created. Wherever model merge allows you, it actually adds a node where things intersect, which is very helpful, we'll see later in this model, but not so helpful in braces where I don't want them to actually share load along their length because of an item we have called physical members. Okay, so that would be a problem for me in this model. So now what I can do here is we can add, I'm going to put a boundary condition on the base of my model. So I'm going to click on Fix Boundary Conditions here and Apply and just highlight the very base of my model and add the boundary conditions. And then one of the things is I'm going to copy this model, and one of the things that is sort of helpful is to get your model aligned with the global axis. It's not always important, but for my model, it helps me to sort of rotate things and copy things if I'm in line with my global axis. So what I'm going to do is rotate my entire model by 30 degrees here just to help me get in line with the global axis. And that'll just help also when I'm doing all sorts of things like loading and copying, that now I'm actually in line with my X direction and my Z direction. Okay, so if I look at this in isometric view, that's what I have kind of as my model. And I do want to add like my actual L-shaped street pole here coming off the top of my model. So the way I can do that is just sort of unselect this portion of the model and select some nodes, and I can copy these nodes off of my model here to project those that are out in that direction. So I'm going to clear that and tell it to copy those nodes by 16 feet. If I copy them over, I see that I've got now nodes in the same direction there, and I can draw in some of my beams. So I click on Draw Beams. Actually, these beams, I'm going to make these fixed. Sort of how do we have those not be fixed? So I'm going to actually have that be cantilevered off there, and I'm going to draw these members out here. So now we've got sort of our beams in place connecting to our columns, and I'll want to draw in some of my lattice work out here. So again, I'm going to click on isometric view. I do click isometric view quite a lot just to get myself back and going, and so I can draw in perspective there. I'm going to draw my webs in place. These will be pinned, so I will say pinned on those, and I can draw in some web elements here. I'm going to see if we got all of those webs in place, and I'm just going to unselect everything in my model and just copy these over by 2 feet so that I can start drawing in a more lattice area in here. So unselect everything, clear it, and -2 feet, and it copies some nodes. So it's real helpful to be able to copy your nodes around a little bit, and so you can get some quick places to click to. I think that's one of the most tools that I use most frequently is copying and moving things so that I can actually manipulate them that way. Okay, so if we do, actually I'm going to unselect that. If I just select this whole area here, what I can do is copy this whole area over to the right, and we can copy it multiple amount of times so that it meets back up with the rest of the build of the tower. So I'm going to use the copy button. I'm going to clear, and then now I'm going to use my copy button to click on here. I'm going to, in the X direction again, I'm going to say it's going to go over 7 increments at -2 times there. So it's going to copy that. I'm going to say apply, and you'll see it'll fill all the way back out into the tower. So I've got all of my members in place. We'll just render it real fast so we see what we're looking at again. Rendering also does take you through the different section cuts and colors, so you can see if you did that properly. That's one of the big mistakes I think folks make is you get halfway through and you're like, wow, I used the wrong members. But if you do kind of phase that through a couple rendering sites, sections here, you can see that how you did it. So I've got webs in place, I've got my beams and my columns, and now the next piece I want to do is put some actual supports in there for my sign. So what I'm going to do is I'm going to just, I'm going to switch back out of there to wireframe just because it's so easy to see that. And I'm going to click on this top node, and I'm going to reverse the colors or selection sets with this button right here, and just select that node. What I can do is copy that node up by 5 feet, and I'm just going to say keep this dialog open. It copies it up. Then I'm going to copy it down by 5 feet and say apply. So if I've got that in place, and I can draw my sign supports to these nodes, and I can click from here to here, and I've got my sign in place. Well, I do want to do it fixed there, so I do have some, so I'm going to just say fully fixed, and I'm going to go there to there. There we go. So now when I have it in place, I do want to copy this over because this sign is going to be all the way across my whole tower up here. So what I'm going to do is I'm going to copy it. I'm going to say unselect there, and I'm just going to copy it over. So I'm going to, this time here, I'm going to do it at three increments at 5 feet. But it's going to go in the negative direction. If you ever wonder what I'm doing negative and positive, you can always make a mistake, okay? If you just do make the mistake and it goes in the wrong direction, like just there, it was supposed to be in the X direction, not the Y. There's an easy thing we can do, just push undo, and then you can see there how easy that was. So we can clear this and just put this in the X direction, 3 at 5 feet. Okay, and again, it's going to be in the negative direction, and as I mentioned here, you can always refer just to this global axis to see which way. You see there it pops in 5 feet. But, you know, I make the mistake all the time, and then I just push the undo button, not a problem. So I'm going to do is, now if you'll notice here, I'm at 5 feet. And so this is an interesting model in that I just drew that sign in at 5 feet, and I didn't, there's no actual node at that location. So right now it's sort of floating in space. The node is what connects it to that member there. So what I will need to do is use I'm going to select the top and bottom members, and I'm going to use my model merge button. And it's going to tell the model to merge there. So I'm going to just say apply, and it's going to merge. Oops, well, we'll have to tell it there to merge. Sorry about that. We're going to have to tell it to merge there, selected items only, and we should merge there for us. Let's double check there. Okay. So we want to merge just that items, just those sign supports. So I can just select those model merge there, and I'm just going to click on that and click on that, and I'm just going to merge these by items only there. And I've now got them merged. So I see that wherever they didn't have joints, they added joints for me. Okay, so next step to do on this model here, we've got model merge done, we've got everything in place. I'm just going to add some loads to this model. So let's click on the basic load cases, and I'm going to call this as dead load, live load, snow load, wind load, and it's on the sign, and wind load on the structure. Okay, and what we'll do here is we're going to call this dead load, we're going to call this snow load, wind load, and wind load. And we're going to put a little self-weight in there from the Y gravity. In the snow load here, what we can do, we can just add some line loads to create that snow load. So I'm going to go in here and I'm going to create some snow loads. The snow loads there are going to be -0.1, -0.1. Kips per running foot. I'm going to call that to be snow load. I'm going to apply that directly on there on the top of the model. So we're basically as if it's the snow is landing right up there. We're going to add some dead loads in here. So I'm going to do the dead loads also. And dead loads here, I'm going to just keep them as a negative. Let's see, the dead loads are going to be -1, but those are going to just be sitting here on the front because that would be basically how our sign is going to be supported by. Okay, so we do some line loads on there. Then we're also going to do some wind loads. The wind loads I'm going to do is going to be applying some area loads in there. The area loads that we can do in this direction here, so we're going to be using the Z direction, okay, which is into the page, into that sign there, and we can put it in as a -0.04, okay, and then what we can tell the program is it's going to be for the wind loads on the sign, it's going to be clicking A to B. And we're going to tell it to click it right on the sign. So I can just click A to B, and it was going to distribute those loads along the distance of that sign. So each one of those supports is going to have a line load, basically, after we're done with this. The program is going to calculate that area load and distribute it to these support elements. And then what we're going to do is put some open line structure. So we have an open structure item there, and I'm going to put that on the structure. And I can say apply, and I can apply that directly to the structure. Now this gets a little, I want to make sure I click on the right ones here. So I can click on this, and what that does is it just loads the actual structure itself. So meaning that if the wind is going to blow right through this structure and only the face of that tube there and the face of that pipe there is going to be loaded with its tributary area or dimension there. So we actually take that 40 kips or 40 pounds per square foot and calculate what the distance there would be on that one member. Okay, so that's a little bit different than what you have when you use a normal area load. Open structure load is a little bit different and is much more used for like this type of structure. Okay, so you've got all of those loads in place there. And we can do is I can just take a quick look everything on the basic load cases. We've got our line loads, we've got our area loads in place, and what we can do is open up our load combination spreadsheet and make sure that we use our LC generator. And our LC generator here, we're going to tell it to be running it as we did go and use gravity. We told it to use snow load this time, so we make sure we have that checked on. And I say generate, and it generates the snow load and the dead loads that we created. And then it's going to create the wind loads. We did not use an X and Z this time, so I'm going to just tell it to do 2D only but reversible. And it applies it in 2 dimensions just using the WL and in reversible, so positive and negative. Okay, so you've got all that in place. What I'm going to do is unselect the model and just make sure we don't have any problems with our model merge real fast. I'm going to just select the web elements and reverse that and do one quick model merge just to make sure I didn't copy things incorrectly there. Okay, so it looks like I did have a couple of duplicate joints there, so it did help clean up my model slightly there. Okay, so with all of that in place, I can run my model. I'm going to run this envelope solution. So you can solve this model and run it, and it's going through all the load combinations. This one should be a lot faster, okay, because we're not doing an iteration. If you notice on the bottom of the screen, there's no iteration of 1, 2, 3, okay, but what we do have is we've got our design results on our screen. We can pop open our design results, and we can see here, I'm going to sort this. It looks like I do have some pretty bad failures, a little bit. Not too bad, but one thing we didn't address is our unbraced length, okay, so you do want to pay attention to your unbraced length, and that could be really what kills me on a lot of these members. So before we go into too much depth in this, let's take a look at our unbraced length for our members. So we look at one of these members here. We have something called an LBYY and an LBZZ. And I'm just going to show that quickly on my screen, looking at my local axis. Okay, so each one of the members has an LBYY and an LBZZ, which is the unbraced length about the Y and about the Z. And so if we just select only one member, just so we can just really focus on this. If you think about this as your right-hand rule, it's the bending about the Y there. So if you stick your thumb in the direction of the Y and you use your fingers as your right-hand rule, you'll think about what braces your LBYY and what braces your LBZZ. And so actually for a lot of our beams, since we are sort of so symmetrical in this, it really does everything braces my LBYY and LBZZ. We also do our compression flange top and bottom. So all of those things can be defined in here using something we say LBYY and LBZZ. So you will want to make sure you address these or else you're not going to get a real great code check. So what I'm going to tell the program is using a tool called segment. It tells the program that every time we hit a node that it's going to be a brace point for that direction. And I'm going to do that for my LBYY, my LBZZ, my LComp top, which is my compression flange on the top, and my compression flange on the bottom. And that's since we are so symmetrical in this model and how we're bracing things, that's pretty easy to say that everything is being braced on that. Now that's kind of a pain to do by double-clicking each one, but you can open up your members spreadsheet real quick and go over to the aluminum tab, and you can fix it all up in here real fast. One of the things I'm going to do is sort my members spreadsheet here so that it goes from low to high, and it puts all the columns and beams together, okay? And then I'm going to pop over to the aluminum tab here, and I can highlight everything in that whole area, okay? Beams and columns, LBYY, Z, comp top, and comp bottom. And I can right-click, and I can say fill the block with the segment, or you can just type S, and say OK, and it fills it all in for me. Okay, now I'm addressing my columns there, just the same kind of issue, LBYY and LBZZ, and I've got all that in place. So we'll just go back to no labeling, and we can look at this model a little bit better. So now let's solve it one more time using the envelope, and now we're going to be a lot closer to the true answer there. Starting right off the bat, you're going to have a problem with just addressing that unbraced length. So we would want to make sure we do that probably before we even reviewed results. Okay, so code check, we're going to do a sort on this and kind of look at an absolute code check there. And so I still got some little failures happening. There would be some we would need to size this up a little bit. Let's look at our screen again and take a look at the code check colors. And we can actually take a look at the labeling. It tells us what the code check was. So, okay, so it's, again, we are pretty symmetric, right? We see a lot of symmetric failures. So we see the columns out here are failing. We see the beams are failing. So it does make a little bit of sense there as we see, okay, we got to address those, right? So let's take a closer look, and we'll see which one is actually causing some of these failures, which load combination. Looks like 6 is on the top of the list. So what I'm going to do is solve for, let's see here, 5 or 6. So I'm going to go ahead and solve for our combination 5. Let's do that one. Solve that combination. And we'll just look at that one in particular, and we'll see how there's some failures in here, obviously. And what we'll do is we'll click on our detail report, and we'll go a little closer into this one here. Okay, and we can see really what's failing and why. And so as I look at this here, what I see is I'm going to be looking, as I scroll down here, what is causing some problems. It looks like 4.1.1-2 is actually the failure mechanism, which is an axial plus bending in the X and the Z. Okay, so you have a little bit of actually bending in both directions, so you can see that there. Obviously, the MY is a lot larger. We're seeing 17 feet in that one. So we can look a little bit about for the bending here, what's happening in there. Okay, and we can sort of address this as we go a little bit farther into this one member. You might want to see what can be sized up for that. So as you go into this a little bit farther, what I also would do is I'd go back to my suggested shapes, and I would say, let's take a look. I really don't want to address the webs or the sign support, but I do need to fix up those columns and those beams. So the program is suggesting go to an 8x, and I'm going to tell the program to do that by right-clicking and say Solve Again. I'm going to let the program redesign this. It's going to rerun the model, and we're going to pick up those new shapes, and we're going to see here now what's the failure, and I can sort this new Unity checklist, and I see, so still a little bit of failure, but now we're in the webs. We're still failing. Okay, so we might want to start to maybe divide these. We can start saying, okay, the columns, the tower portion is a little bit larger, so we might want to size those up separately, and then start to assign those separately. But we can do all sorts of things with the actual sizing of those members. One of the pieces, let me turn this off before we get out of there. I do really want to make sure you understood how the area loads got applied, and that's an important point here, is that we've got the data entry toolbar, and we added our own, on our basic load cases, we added our own dead load, snow loads, and wind loads. But now you'll notice that there's these transient area loads, and I mentioned that it would do this, but I want to make sure you see how it did it. So under basic load case 3, that was the transient area loads that we saw how I applied those loads to those members, and it's actually getting applied right directly to those members that I had the area load applied to it. Okay, so that was the wind on the signs, and you see that was there. And if I look at here on the wind on the actual structure, I see I get wind directly on the structure there, and that we see that when we put that wind load on there, it breaks it down into a line load that we can even see a little bit farther per each member. Okay, so definitely something that you want to look at and make sure that you did the loading the way you thought you were doing it. Okay, so we've got all that laid out, and basically that would be kind of the end of this model. We would sort of probably go through and make sure we sized up our webs a little bit. But I think we've covered a lot of the different topics we've got here. And I'd like to just sort of jump back here and talk about, if you have any questions further, please feel free. We went a little bit over what we were talking about here with an hour, but we'll stay on here at least for another 5 minutes to help answer some questions. If you have any more questions beyond that, again, please check our website, www.risatech.com. We're going to be posting our question and answers on our website, so you can see what everybody else has been asking during this webinar, but also you can see any other posts we have on aluminum and information you can find there.